Okay, good morning again. Hello, everyone. As I've said, welcome to the first I-SEAMORE webinar on the topic of the use of AI in border security. We are specifically thrilled to have such a distinguished group of participants, presenters, and synergy projects joining us for this webinar today. My name is Josipa Arapovic. I work at F-Success, partner of the I-SEAMORE project, which is the host of today's webinar. And I'll be moderating today's session, which will explore the cutting-edge uses of AI in border security across different EU projects. To give you a quick overview on your screen, you can see that today we will hear from several prominent EU projects, most notably I-SEAMORE, ODYSSEUS, BAG-INTEL, and FLEXI-Cross. Each project brings a unique perspective on enhancing security and operational efficiency through artificial intelligence from different aspects, from maritime to airport, custom operations, and border management. And on the agenda, we have today a few minutes for introductory remarks, followed by different project presentations. Each project presentation will be lasting about 20 minutes, including a Q&A session at the end of each session. At the end, we will summarize key takeaways and discuss upcoming opportunities for further collaboration. Before we begin with the webinar, just to give you a few housekeeping notes. This session and this webinar is recorded and will be shared on the I-SEAMORE's and the Synergy Project social channels. We also encourage you to ask questions during each Q&A session, whether in the chat or by raising your hand and asking the speakers directly, which we'll have time for after each of the presentation. So without further ado, let's start with the presentation. The first presentation will be on the I-SEAMORE project. I am pleased to introduce our first speaker, who is Gregor Palvin from Thales Group, who represents the I-SEAMORE project. I-SEAMORE is a Horizon Europe funded initiative that aims to develop an advanced ecosystem and platform for maritime operations. The project is geared towards enhancing situational awareness and operational capacity for European maritime authorities. Gregor today will cover the motivations behind using AI in maritime security, the main challenges, and the innovative AI technologies applied within I-SEAMORE. He'll also touch on the importance of trustworthiness in AI-based solutions and how they are evaluated. So, Gregor, over to you. You can start sharing your screen and give us your presentation. Sorry, Gregor, you're muted, so you can unmute yourself.
Sorry. Thank you very much, Josipa. So can you see my screen? The slides are coming now. Can you see the slides?
Yes, we can.
Yeah,
perfect.
Great. So so I'll be talking about how the AI-based solutions are used for improved situation awareness in the I-SEAMORE project. So as Josipa already nicely explained the context of the I-SEAMORE, I will not go into this. I will not talk about that anymore. But as she said, situation awareness is an important part of the solutions being developed in I-SEAMORE. Now, one of the big problems in situation awareness is that decision-making requires actionable information. Examples of action information are an alert about an anomalous track behavior. For example, here on the right-hand side, we see a ship that veered off a shipping lane. But then another example is a warning about a potential drug transfer action in some area. Another example would be alert about likely human trafficking event at some other location. And there are many more examples of actionable information. Now, on the other hand, we have different sensors that provide relevant data. So we have radars, we have different cameras and UAVs, we have satellites, etc. Now, each of these sensors provides a different view, a partial view of the overall situation. For example, if we take a look at this drug transfer event, Then we see radar sees one part of the track of the merchant ship, the weird of the shipping lane. Then two other UAVs might be seeing the little boat that's approaching some rendezvous place, etc. So in most of the cases, the sensors themselves do not deliver actionable information. And that's a challenge. The actionable information is hidden in large amounts of data that are produced by these sensors. So, and of course, the sensor data is data from a specific situation is correlated. But in order to understand what it means, in order to extract actual information, we need models that represent the data correlations, and we need inference algorithms that allow reasoning about these correlations. So, and each decision support function requires a specific model and inference algorithm. And in general, there are no universal solutions or superior models or algorithms, despite many hypes that we see come and go. The fact is that each function requires a well-chosen, balanced combination of algorithms and models. For example, anomaly detector, track classifier, or all kinds of event detectors used in I-SEAMORE require all different models and also different inference algorithms. So, and it's even more complicated. If we want to make sense out of the data that we are confronted with in I-SEAMORE types of use cases, then we're dealing with complex correlations. And that means that the models are not trivial and also non-trivial inferences required. And in that kind of settings, it makes sense to combine different types of models and algorithms. So this is sometimes called hybrid AI or sometimes multimodal AI. And that's something that's really important in the I-SEAMORE types of problems. So there's a little example of a fusion architecture of a fusion function, the rendezvous alerting in I-SEAMORE. As you can see, there are different components of this function. There are certain components are observing the behavior of the merchant vessel in our rendezvous alerting example. And some other components are capable of analyzing the data from the sensors observing the small boat. And then the outputs of these different fusion or inference functions are then combined at a higher level where we figure out whether this is a rendezvous with a high likelihood or not. So we have different types of reasoning, right? Reasoning about the tracks, reasoning about the objects, and reasoning about combination of all kinds of patterns, which is the complex events. Now, today I cannot explain everything because it's quite a rich combination of technologies, but I will zoom into how we solve in I-SEAMORE the behavior anomaly detection and vessel classification functions. So in I-SEAMORE, we apply hybrid transfer learning. It's recently developed method that's combining different types of AI models. It is combining probabilistic graphical models. It's in different types of neural networks, such as variational autoencoders and convolutional neural networks. Now, the probabilistic graphical models, short PGM, allowed fast training in the context. That's very important. If we have kinematic data, we always have to train in the context. We cannot have a universal model that will correctly interpret kinematics anywhere in the world. It must be learned in the area of mission. And that must be fast. PGMs allow that. Then variational autoencoders are typically pre-trained models that represent high fidelity models of kinematic behaviors, fine-grained models. And the convolutional neural networks, in our case, are used for advanced image interpretation. And by using expectation maximization algorithm, we are fusing together the PGMs with these neural networks in a sequence. So with this EM algorithm, this machine learning, it's unsupervised machine learning, we glue these models together and we get a new version of a classifier, which is now has all the good properties of PGM, is very robust, is in the context, but it adds all the sophisticated features from the VAE. Now, if we add a new sensor, we have some electro-optical sensors, cameras, then we have a pre-trained convolutional neural network, which is again in the same fashion added to the hybrid classifier version 1, and we get even more sophisticated model. So this is a form of frugal learning where we minimize the required data quantities for training. Very important aspect if we're talking about the real-world operation. So, sorry. Now, this type of transfer learning is at the core of our anomaly detector and the track classifier. So the anomaly detector is using only kinematic data, but it's combining AIS and tracks from radars. Now, why do we have to combine things? Is because the PGM is a context model, but the variation autoencoder allows to interpret very fine-grained behaviors of tracks that the PGM cannot capture. In that way, as you will see in the results later, we get very robust and very well-performant model. The hybrid classifier is fusing kinematic data with imagery by using convolutional neural networks. So, and of course, if we zoom in the previous composite fusion function example, dealing with detection of rendezvous, then we see that these hybrid models are used in part of the entire architecture. And then these outputs are then fused at a higher level, typically with rule-based solutions. So the detection of the actual event, which is combining all kinds of conclusions from other models throughout the architecture, is based on rules. Because at that level, we do not have a lot of data to train these models. So therefore, we use rules. And also, these models depend heavily on knowledge, on the domain knowledge of the users, and they depend on the mission they should be modified. So that's an example of such a hybrid architecture. Now, so we have machinery which we can use and with which we can efficiently build systems. But now the other question is this trustable? Because these functions are used for mission critical applications. So by missing an event, it will be a problem, but also by having false positives, this is also not good. These are all misleading results that can jeopardize the mission. So in order to get trustable solutions, but also frugal, that means that we can train them, that it's cheap to do that. And in order to do that, we have to choose the right types of AI techniques, the techniques that have the capacity to absorb the knowledge from the data and do that efficiently. Also, we need a very sound rationale for the modeling assumptions and simplifications. These are not black box models in the sense that we don't understand how the algorithms work. It's very important because by having this rationale, we know the properties of these solutions. Then we have to collect sufficient amount of training and testing data, which is always a challenge. Therefore, it's critical that we have some kind of frugal approaches so we can get our results with small training data sets. This small means relative. Here we are saying we might still need thousands of tracks, but we do not need millions of tracks, which some other machine learning techniques might require. So that has to do again with the choice of the right AI techniques. Now, after we have this data, we have to show proof that the expected accuracy of these functions exceeds some minimum requirements. And that means that we have to carry out sound evaluation of these things. This is experimentation with real-world data. That means we need sound evaluation process, but also metrics. And also, we have to be able to monitor the correctness of trained models. And this can happen at different levels. It's for the engineers to monitor whether these things have learned sensible things, but also for the users at runtime. So this implies different types of explainability. And then also, we have to understand the failure modes. So for that, we have to carry out theoretical analysis. Here I'm coming back to the sound rationale for the modeling assumptions, because we cannot test everything through black box testing. We simply don't have enough data. So therefore, we have to understand it up front. So we have to build the so-called failure models. So I will not explain all these elements today because I don't have time, but I will dive into the evaluation with real-world data. So here I will show some results for the classifier and for the anomaly detector. So the classifier was evaluated with real-world data that was collected from different sources in the area where the I-SEAMORE is supposed to operate, at least where the demos will be taking place. And the classifier can classify between different types of ships, such as merchant, passenger, fishing, tug tow, and other. Now, what's interesting, I will not show all the evaluation metrics we used. I will just show the overall error rate today. But what we can see is that as we use progressively sophisticated architectures, we improve the performance, which is the classification performance. And here, if we have a pure PGM, pure graphical model, which is just a coarse kinematic model, we get the classification error rate of 7.5%. Now, if we add the advanced fine-grained kinematic feature in form of VAE, we already slash the error rate by 1%, which is actually improvement of more than 13%. And it's for free. We have not, we didn't need more data, nothing. So if we even add the CNN, which is convolutional neural network, which is now interpreting the imagery associated with these tracks, we actually end up with very low error rates. More than 50% we have slashed the error rates. Now, what's interesting is that the CNN alone that we added doesn't have an overwhelming performance. It still has 8.4% error rate, but we can see that the sum of parts, this is more than just the sum of parts if we do this kind of fusion of models through transfer learning. So, and this is now at the end, this is an example how we fuse by using the AI-based models supported by machine learning. In the case of the hybrid anomaly detector, the problem is different. Here we don't have multiple classes, but the definition of anomaly is a bit problematic. It's not trivial. So, and we made different experiments. So we would take the real tracks and then we would synthetically add anomalies. So we modified some features. We added some speed or whatever. But this is easy. So therefore, this anomaly detector worked almost perfectly. But what's more interesting is the natural anomalies, because they have like there's subtle deviations. For example, a track gets a bit too fast, the heading is too much to the east, etc. And the question is whether that would work well there. So, and we got those anomalies by getting tracks around incidents. So there's a database of incidents, and we found the AIS tracks in this case associated with those incidents. And then we trained the hybrid anomaly detector, and these are the results that we obtained. So the true positive rate is pretty good, I would say, but false positive rate as well. So, and that's important because anomaly detectors often, if they have a good true positive rate, they don't have a good false positive rate, which would be as low as possible. Now, this is all nice. These are results with a certain snapshot of the data that we obtain from the real world. But there are also robustness questions. So what we will always experience in the real world is distribution shifts. The behavior of ships will change with seasons, with economical and political situations. So if we train them all today, it might be we might need different correlations in a few months because there's a political problem with Iran or something like that. So we have to be able to quickly relearn the models in the context. And that's exactly what the PGMs allow to do. So we can continuously relearn the model every once in a while. And it's important because we can do that with simple data. But PGMs will work already with kinematic data we collected with radars or AIS. We can also automatically detect distribution shifts. It's more advanced, but by simply relearning, we're already solving many problems. The other problem is that I was talking about adding sophisticated neural networks. But what happens if these neural networks are heavily biased? And they will always be. So the remedy is that this transfer learning actually identifies the conditions under which the biases in these neural networks are damaging to the overall performance. And there's also another property, which is that the hybrid model cannot perform worse than the base PGM. That's a very important property. If we have enough data for transfer learning, which is few hundred tracks typically, which we have. And the other one is missing inputs. So not always will have all the data points. So, and that's taken care with the high-level Bayesian inference that happens in PGM. Now to conclude, we have to solve challenging functions. We have to extract actual information by analyzing complex correlations. For this, we need good models and algorithms. And we have to deal with noisy sources and distribution shifts. Now, in order to address that, we use hybrid AI solution. And by combining different types of AI, we get high performance, robust fusion functions. And one of the methods that allows to do that efficiently is hybrid transfer learning that I just described before, which is combining probabilistic graphical models and neural networks. So what's important is that these solutions should allow, and they do allow, fast training in the context. And where we also reuse the pre-trained models. So again, here we are going into the frugal learning. And it's open-ended and non-intrusive with respect to legacy assets. There are all kinds of asset sensor systems, platforms that exist, and we want to tap all sources, fuse it, and shoot back the results. And of course, we evaluate these things in a sound way with a lot of data. So we are quite confident at least some of these models work well. And we saw the properties that we can get a huge boost if we reuse also VAEs and CNNs. So with this, I would like to conclude my presentation. Thank you for your attention.
Thank you, Gregor, for that insightful presentation on the topic of I-SEAMORE's approach to leveraging AI for maritime security. Now we'll briefly open the floor for a brief Q&A session. You can ask Gregor directly the questions by raising your hand or by posting your questions in the chat. I don't see thus far any questions. Okay, if there are no questions, remember that you can still ask or post your questions until the end of the webinar. Gregor, thank you again. And yeah, please feel free to type your questions in the chat. We can also answer them later on. Okay, to move on, I see, yeah, just a participant saying that it's a very interesting presentation, and thank you, Gregor. Our next presentation today will be led by Mr. George Agapio from Wings ICT Solutions, presenting the FLEXI-Cross project. FLEXI-Cross focuses on deploying innovative solutions that streamline and secure border processes that enhance both traveler experience and security using AI, IoT, and predictive analytics. George will discuss FLEXI-Cross vision and then focus on their approach to creating flexible and modular border processes. George, thank you for being here today. Please feel free to share your screen and start your presentation.
Thank you, Josipa. Let me share my screen. Is it okay? Is it?
It's still loading from my side. Yes, now we can see it. Go ahead.
No, okay, great. Sorry, there is a bit of delay because of, let's say, of the internet delay. So my name is George Agapio. I'm working in Wings. Wings is an SME company here in Greece, in Athens. So what I'm going to present is the AI capabilities in cross-border checking techniques. These slides were made also with the help of my colleague Giuseppe Vella. To provide an outline of my talk, I will present briefly the project, then the use cases, and then I will move straight ahead in the artificial intelligence techniques that we use in cross-borders scenarios. So here you can see a very short overview of the project. It's a 3-year project started in September 22 and finishes in August 25. So here we can see the main challenges of the idea of the FLEXI-Cross is to build a continuous validation toolkit that can provide checking solutions in cross-border environments, in ports, and also in terrestrial areas. So here on the left, you can see the challenges, and on the right, you can see what solutions we propose and we implement in the project. So the challenge is that we have a lot of increase in freight and passenger transport in Europe. So the idea is to use the available technologies of artificial intelligence, machine learning, big data analytics in order to overcome these challenges. Also in Europe, we have quite a bit of human trafficking, irregular crossings in cross borders. We have contraband smuggling. And the idea is to invent intelligent remote mobile checks for those people and goods. We have a lot of entry and exit systems where quite a few countries, I mean, not few, but many countries here in Europe. Of course, we have sea borders and we have also terrestrial borders. So it's very easy for people to come through the sea and also through the terrestrial borders. And what we do is the idea is to find solutions that we can build on the top of legacy equipment that the officials are using in the borders. So we try to find some innovations on top of this in order to increase the security and to prevent the smuggling possibly in these borders. And of course, we need technologies like automated border control systems using biometrics and automatic borderlands. And that's the idea that we use some ad hoc solutions in order to increase the lanes of a cross-boarding in order to minimize the time of passengers that need to pass through this border. Here you can see the 3 use cases that we use, but I will concentrate on the first 2 use cases, since for those use cases we use some AI techniques. So we have use case 1, which is a use case that takes place in the Galati port in Romania. And here we have possible smuggling for people who try to invade inside the ship illegally. The use case 2 is implementing the border of between Greece and Bulgaria. In Armenia, it's on the north of Greece. So there's a border that we need to test this some possible smuggling and trafficking in that area. If I move to the next slide, here you can see some experiments that we have done in the port. We have a ship and passengers that try to embark and disembark from the ship. So the scenario was that a crew member tries to invade the control, and what we do is that we have what we call Phase VI mobile application, so that the traveler or the passenger that tries to invade, he has installed this mobile application in his mobile. So it takes through the application, it takes a photo of his face. Now this photo is passed to a server to verify the identification by checking the photo taken with some pre-stored photos from all European, let's say, persons. And the application then verifies or misidentifies the person in case that this is an invader. So that's the main idea of this scenario. And we use, of course, artificial intelligence in order to verify some special features of the face of the person. Here you can see another slide of this scenario. So this is a photo that is taken from a traveler who embarks the ship. And we try to use some open computer vision with AI tools to extract some specific characteristics of the eyes, the mouth, or the nose in order to identify if this is the correct or the truth person that is taking the photo on his mobile. Again, you can see here on the right, the Face VI application that the traveler is using is taking a photo. This photo is passed to a server, as we said, and this server tries to identify if this is the right person. And the application is doing also a verification of the correct face with a face which is stored in the premises of the administration. So the results that what we get is either a verified and identified person, correct person, or a misidentification of a wrong person. And to do this, in order to extract some specific characteristics of the person and his face, mouth, nose, eyes, we use some AI deep learning algorithms for the face verification and identification. Here you can see also another scenario that we have where we use we have as components, we have an RSU camera, a roadside unit camera, that what it does is taking video of the, is taking a photo of the vehicles that come very close to the cross border, and it identifies some U-turns or unlawful parking events that are taking place in the cross border. The idea is to find from those not, let's say, legal or lawful traffic patterns to identify in extreme situations for illegal passengers and vehicles. And we use trained algorithms because in order to detect those U-turns, or especially for the U-turns, we need to use some historic data of how a U-turn. I have a slide later to show. Here you can see it. So what we do is we take this, as we said, the video from the RSU camera. Then this video is passed to a server, a local server, a central server. This server is processing the video. Then we have some historic data of how a U-turn is considered. And you can see we have some trajectory data for the U-turns and also for the unlawful parking. And this is the way we can understand that if some unlawful actions are taken by some vehicles, so a signal is sent to the operator to take some action for those vehicles. Here we have another component. It's a UAV. It has a camera, a drone with a camera integrated in the drone. And what it does is it's taking a video of the surrounding. It identifies either any person or any vehicle that tries to invade the cross border. And by using some CNN trained algorithms, it identifies either the person of the face of the person, or any unlawful traffic action by the vehicles. Here we have another technique where we use acoustic sensing, so that there's a module in the officer that says a signal. It receives the reflected signal and tries to classify this into a category. And by using some AI algorithms, we try to predict the position, to identify the cargo that's inside the vehicle, if there is any contraband smuggling or human trafficking, to detect all those, let's say, unusual patterns that can occur in a cross-border. Here I can pretty much summarize what I present with the components that we use for the cross-border in the terrestrial case in Armenia between Greece and Bulgaria. That's what we call living being detection. So we use, you can see here on the camera, if you can see my cursor, we use either a camera, either on the drone or a fixed camera, a tether camera on the drone. We use some OBU gateways integrated with different sensors, CO2 sensor, proximity sensor, GPS, can have also a camera. And on the top of this, we have what we call a citizen mobile application that the traveler can have in his mobile in order to eliminate or to decrease the time that is taken for a vehicle to cross. So what this application is doing, you can see it here on the right, the user is logging in and it has to put some different identifications. For example, it has to take a photo of his face or a fingerprint photo, and these photos are taken then to a central place, here, to a central place. Those are checked with stored data for all passengers. And then the system identifies if there is any misidentification or if there is any illegal trafficking or drug trafficking in the cross-border. So the idea is to use different kind of components. We use these components are sending video or any other type of data to a central server. We use some convolutional neural network processing in the server in order to identify the face or some specific characteristics either of the vehicle, the cargo, or the traveler. And then we send some signal either to the officer in the cross-border, notifying him either for a possibility of some illegal action either by the traveler or by the vehicle. And pretty much, I think that's all I had to say. Thank you. If you have any questions, please.
Thank you, George, for illustrating how FLEXI-Cross is driving innovation in border security. Like George said, now we'll take some questions, if there are questions for the FLEXI-Cross presentation. As always, please feel free to use the chat or raise your hand directly if you'd like to ask a question to the speaker directly. I guess it was really clear. George, thank you again.
Thank you.
If there are no questions at this point, we can move on to our next presenter. I am excited to present to you also Philippos Onafoudakis, representing SQD and the ODYSSEUS project. ODYSSEUS is a European project focused on improving the border crossing experience for both travelers and border authorities by leveraging AI-driven decision support systems. The project prioritizes secure and efficient border management and also focuses on safeguarding passengers' rights. Philippos will explain how AI is used to optimize the border processes, the role of explainable AI for transparency, and the overall benefits of those systems for all of the stakeholders involved. Philippos, thank you for joining us today, and yeah, you may share your presentations and start.
So hi everyone. So let me know if you can see my screen. Okay, perfect.
Yes.
Okay, nice. So thank you for joining today. And for the introduction, I'm Philippos Onafoudakis. I work as a machine learning engineer at SquareDev. So basically, I'm more of a technical guy. I will try to explain you in a high level the technologies that we use in ODYSSEUS project. So to begin with, this project focuses on using artificial intelligence to enhance the security and efficiency of border crossing processes. while also elevating the traveler experience. So let's dive into the details. So here's what we'll cover today. First of all, a brief introduction of the ODYSSEUS project, so we can better understand the technologies it includes and the utility of each module. Also, we'll talk about how AI-driven decision support systems enable these seamless border crossings. We'll talk about the explainable AI, the role of XAI in ensuring transparency, and of course, the benefits of the system for both border authorities and for travelers. So ODYSSEUS is a 3-year project funded by the European Union's Horizon Europe program. It started in January 2023 and is set to conclude by December 2025. The main goal is to create a more seamless travel experience for passengers while improving the efficiency and speed of border control processes. And for this, we use a platform that leverages cutting-edge technologies like artificial intelligence, biometrics, mobile devices, digital identity verification, and UAV or drone, if you like it, based surveillance, all designed to make border crossings more secure and efficient. So ODYSSEUS brings together several technologies. These include 4 types of technologies. First of all, digital identity. So let's imagine a world where your passport resides securely on your smartphone, eliminating the worry of loss of theft. So basically, ODYSSEUS can make this reality with DTC or the digital travel credential. This digital version of the passport enables faster processing and enhanced security. Also, ODYSSEUS employs AI-powered behavioral verification technology, which actually uses the app and the patterns that we use while we open the app, which continuously authenticates travelers based on their unique patterns. So another type of technology is the vehicle screening. ODYSSEUS uses technologies like non-obtrusive and safe X-ray technologies for vehicle scanning. Also, we use UAV-assisted vehicle scanning, which deploys thermal and high-resolution cameras mounted on drones for detailed data. Also, ODYSSEUS offers multiple options, all designed to be fast, secure, and user-friendly for border crossing, including seamless identity verification and faceless travelers counting to ensure privacy, of course, while managing the travelers' flow. And finally, at the core of the platform, there is the DSS, what we call, or multimodal fusion and decision support system, which is equipped with XAI. And this allows for transparent and reliable decision making processes. So basically, this system helps to analyze data and generate risk scores. And we enable, with this way, the border authorities to make informed decisions really quick. So the decision support system, or the DSS, is central to ODYSSEUS. It collects data from various sources like thermal cameras, digital passports, and X-ray scanners. And this system uses this data to assist stakeholders in making well-informed decisions. So the DSS can identify potential threats and suggest the appropriate course of actions. The DSS supports 3 primary types of risk assessment: traveler risk, vehicle risk, and area risk. For travelers, it uses digital passport data combined with continuous behavioral authentication to verify their identities. For vehicles, the system relies on X-ray and the UAV scanning to detect anomalies. And finally, for area risk, it involves detecting people in unauthorized areas who may be attempting to cross borders illegally. And each of these components works together to create a risk profile that informs the border officer decisions. The DSS is responsible for collecting all the results, and with a proper assignment of weights, it produces an overall score. This score, of course, it can be seen as green or red in cases where suspicious activity is detected. And the important part is that we can manually custom made this DSS for each scenario. So, for example, in a scenario where checks occur at night, and as you can imagine, the accuracy of the UAV-mounted RGB cameras may be reduced, we would give less weight to their results. However, since temperature differences are more pronounced at night, thermal cameras provide more reliable results. So we would assign more weights, or say bigger weights, to models that account for this. But of course, in any case, every result will be displayed on the DSS Decision Support System dashboard, so that the border authorities can also conduct manual checks, ignore why the AI models make specific decisions. Sorry, just to interrupt you. I got a message that my internet is unstable, so let me know if you can't hear me or you can't see my screen.
We can, it was just a brief interruption,
Perfect.
let's say half a minute. So if you can just maybe go back to what you were saying half a minute ago, I think it should be okay.
Okay,
Sorry,
okay. Yeah, no worries, of course. This happens, yeah, of course. So, okay, so I will discuss again a little bit about how the DSS creates this risk score and give you an example. So the DSS it's responsible for proper assignment of weights, and it's very important to mention that we can custom and change the behavior of the DSS. So an example and a real case scenario that we faced is that in a scenario where checks occur at night and the accuracy of the RGB cameras may be reduced, we would give smaller weight or less importance to the result of these models. But however, since the temperature is more, the temperature differences is more pronounced, we would give higher weights to the thermal cameras. So basically, we can change the behavior of the DSS and adjust it to each scenario. Of course, every result will be displayed on the DSS. The border authorities can see these results and can also conduct manual checks, ignore an alert, or investigate further. So now we can talk a little bit about the XAI module. So one of the key aspects of ODYSSEUS is the use of XAI. XAI is critical because it allows us to understand why the specific models make these decisions. This transparency allows border officers to understand the rationale behind each risk score and its recommendation. And this way, the system is more trustworthy and more understandable. So XAI enables to treat AI not as a black box, but as a tool that we can question, understand, and of course, improve. So XAI provides three main benefits: transparency, the ability to reveal hidden patterns, and of course, to improve the model performance. It allows us to see what factors influenced a particular decision such as specific pixels in an X-ray scan or data from thermal cameras. And by understanding these insights, we can refine our models, ensuring that they are more accurate and, of course, fair. So this builds trust in the AI system among users and, of course, stakeholders. To give you also a real case scenario and a more concrete example, imagine we have the human detector that detects people inside cars using thermal cameras. So this detector will respond with a number. So let's say it detected 3 people. Then we will compare this number to see if it matches the number of people declared to be inside that they all already have registered. And if the number doesn't match, we want to understand why the detectors produce a different result, and more specifically, identify which pixels were detected as people. In a different case, for example, of behavioral authentication, where the model collects tabular data, which is the pattern that the user makes in the DSS app. We want to know which specific features and characteristics led the model to decide whether the user is legit or an imposter. So 3 models that will be equipped with XAI, and of course the XAI will report, the reports will improve the experience and also prove to be very crucial, is X-ray scanning, thermal imaging, and behavioral authentication, for all the reasons that we discussed in the previous slides. Now, so we will discuss about the DSS benefits. The project offers basically a win-win scenario for both border authorities and for travelers. First of all, we need to discuss about the challenges and talk about how DSS is designed to address some of the major challenges in border management, like rising traffic volumes, evolving security threats, and resource constraints. So let's say traditional border checks rely heavily on manual processes, which can be time-consuming and, of course, inefficient. And by integrating AI-driven technologies with ODYSSEUS, we can automate many of these tasks, free up, of course, the resources, and reduce the processing times. And this is not only a huge benefit for the border authorities, but of course, it enhances the travel experience for the passengers. So let's discuss some benefits for the travelers. So first of all, we have faster and more seamless border crossings. Basically, we say goodbye to long queues and delays. ODYSSEUS streamlines border crossing procedures and allowing travelers to reach their destination more quickly and with less hassle. With DTC and the digital passport, we offer a secure and convenient way to carry your travel documents on your smartphone. Next, travelers can pre-register their travel details and digitally submit required information in advance. And this way, we're expediting the processing of border control. We also have a lot of security, enhanced security. The platform's multi-layered security features, including continuous behavioral authentication, protect travelers' digital identities and personal data. And the sales is designed with privacy, complying with GDPR and all other relevant data protection regulations. So continue, we go to the benefits for border authorities. So first of all, it enables targeted inspections. So the DSS allows border authorities to focus their resources on high-risk individuals and vehicles, optimizing efficiency and maximizing security. We have real-time threat detection. The system provides real-time alerts and recommendation, We also have improved situational awareness by integrating data from various sources. The platform creates a comprehensive view of border operations, enhancing situational awareness and facilitating better decision-making. Of course, the DSS equips border officers with detailed risk assessment and insights, enable them to make informed decisions based on objective data. Lastly, we have transparency with XAI and explainability. We use explanations for every decision, and with this way, actually, we enhance the trust in the system. So closing, we believe that ODYSSEUS represent a step forward in how we approach border security. And feel free to join our website for any detailed update. And so basically that's the presentation. Thank you for your time, and I'm happy to take any questions.
Thank you, Philippos, for sharing how ODYSSEUS is advancing secure and efficient border management. Yes, as Philippos said, as always, please use the chat or raise your hand if you'd like to ask a question to Philippos directly. I'll leave. Yeah, Gregor, go ahead.
Thank you for the nice presentation. I have one question. You're mentioning those weights for the results of different modalities, right? Of different models. How do you determine these weights? Is that manually determined through experience of the user, or is there some automated way of figuring that out?
Exactly. So basically, we start with manually. We decide manually the weights and how high or maybe low they are, and we use some real case scenarios to see if these weights are basically correct or wrong. And we also use we have used some literature review to see actually if some modules are really significant or not. And so for the next steps, actually, we're planning to use some machine learning algorithm to determine these weights. But for now, basically, it's more of a manual process.
Yeah, thank you.
Thank you.
Thank you, Gregor, for asking the questions. Any other questions for Philippos? Okay, you can either ask them now by raising your hand or just post them in the chat. If there are no questions at this point, I'd like to thank you again. And we can move on to our next presenter. So yeah, moving on to our final presentation of today's webinar, we welcome Henrik Larsson from Legend Technologies, who will be presenting the BAG-INTEL project. BAG-INTEL is a project which focuses on enhancing custom operations at high traffic airports using advanced AI and also camera technology to identify and track baggage seamlessly. With the growing travel volumes, custom operations have different challenges in re-identifying baggage efficiently and accurately, and BAG-INTEL is addressing all those challenges through innovative AI solutions. Henrik today will discuss how AI-based systems can help customs in risk assessment and improve the efficiency of baggage controls. Henrik, over to you. You can share your presentation and present
Thank
the
you.
project.
Let me share my screen here. Here, I find the right screen. I believe it's this. Can you see it? Good.
Not yet, but
yes, I would like to introduce BAG-INTEL. Which is a research innovation project started 1st of September last year, running for 3 years. So I will introduce with this short video, I will start new.
Henrik, we still can't see your screen. Can you try sharing again?
You cannot see the screen?
No, not yet.
That's right. I will try it again.
Slowly it's starting.
Can you see now?
Yes,
Okay.
thank you.
I will run this short video here, which gives an explanation of it, and can you hear the sound?
No, unfortunately not.
Volume of passengers
yes.
arriving by new inland border airports continues to grow, and so does the need for increased efficiency of baggage customs controls. The BAG-INTEL project was launched to develop an innovative solution that will address this need, boosting the accuracy and effectiveness of baggage customs control without increasing the personnel involved in the process. The BAG-INTEL solution will support the border and customs authorities in detecting and locating luggage containing contraband through its three main components: an AI camera-based end-to-end continuous re-identification of luggage, new functionality for enhanced scanning combining AI-based detection, X-ray absorption technologies, and a digital twin for BAG-INTEL system visualization and performance optimization designed for the operational context of the airport. The solution will help ensure that all baggage is efficiently scanned and that suspicious luggage is then tagged so that the customs staff can easily find it before a manual inspection. The BAG-INTEL solution has many advantages. It features a non-intrusive and environmentally friendly re-identification of luggage, as no physical marks are placed on it. It causes no delays in the flow of passengers, as the unique visual signature of the luggage is captured while it's in motion. It doesn't require extra personnel, and it allows the customs staff to focus only on pieces marked as suspicious, reducing false positive inspections for a streamlined, effective process. And last but not least, features a built-in interoperability, allowing easy interface with legacy systems. The social and technological impacts and benefits of the BAG-INTEL solution will be tested and demonstrated in real life in use cases performed at 3 international airports in 3 different parts of Europe: Finland, Denmark, Thessaloniki, Greece, and Madrid, Spain, covering the necessities of airports of different sizes. Want to know more? Follow us in our journey.
Okay, thank you. So here you see in an overview of the system, how it works in the application context. You can see we have the luggage, the baggage arrive from the flight, go to the baggage conveyor belt through the scanner, which is in this project an X-ray CT scanner. And it goes from there, it goes continuous on the conveyor belt, going to the carousel area. And from the carousel, or also the delivery area, the passenger picks up the luggage and goes out, choose the gate, either the red or the green, and then go out through the customs. So what we do there, we in the scanning is looking for detecting contraband of different kinds, like drugs. So all the bags are then tracked by the cameras. So in case of suspicious bag, it can be re-identified when the traveler goes out through the customs. And if the traveler go out through the green gate, the traveler has implicitly said nothing to declare. And then if something is fine, okay, then it's a problem for the traveler because he's actually trying to smuggle. So let us go on to the next one. So we are using different risk indicators arriving from different kind of what we can call sensors to identify the risk of the luggage, or what we call it, the bag. And they are visualized here. The first one, external data. We are analyzing external data, like the passenger name record, databases from law enforcement agencies, in order to define suspicious travel patterns or linked to organized crime. Because this will raise the risk for this passenger and the luggage brought by this passenger. Then there is another one, important one, is the X-ray CT scanning, which will have use absorption, sensing and object recognition to identify possibly kind of contrabands, which risk also an indication of risk if it finds something. Then, of course, the customs control officer who is monitoring the scanning screen may see something which the scanner does not see, and may then also risk indicate there's something suspicious here. We want this bag to be inspected. And then customs may also apply a dog, we call it a sniff or detection dog, which may indicate something, narcotics or money or something. All these risk indicators are aggregated together in a total luggage risk, based on which we decide if, or the customs control officer decide if the bag must be inspected. And this aggregation, by the way, this is a weighted, a kind of weighted aggregation. And if you ask about how we get the weights, okay, we start with some initial weights we believe, and then the system has a learning algorithm. So based on, we will measure the performance all the time of the system, and so based on how the performance changes, the feedback from the customs who are inspecting, the system will learn and improve the weights all the time. I mean, improve, this means we will increase the effectivity all the time of the system. This here is how it looks for the customs control. This is actually an initial design, which may be improved, but I think you get the idea. The control officer will look and see the scanning images here. And this example was identified something looks like heroin with a certainty of 95%. We show here the location in the bag, the approximate location. And also in this case, it was substance was powder, 340 to 450 grams, purity 90%. And then we see all the risk indicators here. All these risks that are fused to one risk, which is here in the red spot. We have going from red to green. And about some certain threshold, we advise the customs to inspect, as we mean physical inspection, when the passenger is going out with the luggage to the customs area. And if down here we advise, we say no inspection is needed, but the control officer can always click here and require inspection. This is how the interface looks right now. We advancing the state of the art. The security check of outgoing luggage is well developed, we know, and but the custom scanning of ingoing luggage is not developed to its full potential. And this is what we try to help with here with this project. Particularly, one thing, the utilization of external data for risk assessment is in general not exploited to its full potential for customs control. So there is some airports apply another technique, a few airports, for this tracking real identification, namely radio frequency identification, RFID. But this technique has certain disadvantages, which are mentioned here. So I will not. You can read them here. There are certain disadvantages with this kind of or tagging with RFID. implementing the BAG-INTEL solution with advanced features of capability. This include AI-powered functionality for enhanced detection of contraband in X-ray scanning or luggage, AI-powered risk assessment based on the analysis of data from external sources, AI camera-based end-to-end re-identification of luggage, and then a digital twin for system visualization and performance optimization. This will lead to greater effectiveness and efficiency of the customs control processes, like the cases of manual inspection that are not leading to finding contraband will decrease. Since we're only inspect luggage which we have found with a suspect containing contraband, and more contraband will be detected, a small luggage containing contraband will be flagged for inspection. And then besides the AI camera-based tracking and re-identification solution is non-intrusive, which will avoid, since it avoid all the disadvantages of alternative solutions. Okay, thank you. Any questions?
Thank you, Henrik, again for this wonderful presentation and the informative look into BAG-INTEL project and how it's transforming customs operations, specifically for luggage at airports. Again, we'll open up the floor for any questions. In case there are no questions here at this point for either Henrik or other speakers, I would like to thank you all. Thank you, Henrik. Thank you to all of our speakers today, Gregor Palvin, George Agapio, Philippos Orfanodakis, and Henrik Larsen, for their engaging presentations and insights into how AI is transforming border security. To recap today's main points, we heard from I-SEAMORE project, which is focusing on improving maritime situational awareness with trustworthy AI. We heard from ODYSSEUS project, which is focusing on enhancing border processes with AI-driven support systems. BAG-INTEL project showed us how optimizing airport customs through AI-based baggage tracking, and FLEXI-Cross project, which is focusing on streamlining and securing border checks with modular AI solutions. To conclude, as we look ahead, I'm excited to announce that we are planning a follow-up webinar happening in December, which will delve even deeper into these topics and others, and continue our successful collaboration with our fellow sister projects. We'll reach out to you with more details. I want to thank you all for your participation, for your discussions, engagement. We really appreciate your contributions to this important topic on advancing security and efficiency in border control through AI. Finally, to conclude, please remember that today's session has been recorded and will be shared on I-SEAMORE's social media channels and the website. And then also please follow us on our social media channels. All of you will receive today's presentations on your emails along with the recording of today's sessions. And to conclude, on behalf of the entire I-SEAMORE team and the sister project, thank you again for joining us, and we look forward to our continued collaboration. Have a great day.
Thank you so much.
Bye bye. Thank you.
Thank
Bye.
you. Thank you.
Thank you. Bye. Thank you.
Thank you. Bye.